This is section 2.2, the algebra of functions. Algebra as in add, subtract, multiply, and divide. So sums, differences, products, and quotients of functions. Definition. Let f and g be two functions with a common domain. Then, we've got the following four-part definition. Number one, the sum of f and g is noted by f plus g, just like any sum, is given by f plus g of x is equal to f of x plus g of x. If we had to describe this without functions, this would be combining similar terms. Number two, the difference of f and g, denoted by f minus g, just like any difference, is given by f minus g of x is equal to f of x minus g of x. This one would also be described as combine similar terms if we did not have functions. Number three, the product of f and g, denoted as fg, is given by fg of x is f of x times g of x. If I needed a simple word to describe that, I would say FOIL. But if you remember back with polynomials, there was more to multiplying polynomials than FOIL, so in general there's more to multiplying functions than just FOIL. And number four, the quotient of f and g, denoted by f over g, is given by f over g of x is equal to f of x over g of x, provided g of x does not equal 0. So there's our sum, difference, product, and quotient. Let's look at some examples. Number one, I'm going to let f of x equal 2x minus 8. I'm going to let g of x equal 3x squared minus 5x plus 2. We're going to evaluate the following, simplify, and make no attempt to factor your answers. Again, remember, don't factor unless you're specifically told to factor, or if you're solving an equation that has x squared or x to the higher power, then you're supposed to factor, set each factor to 0, or if you're trying to multiply, divide, or simplify rational expressions. Number one, okay, again, there are functions sitting for us. F plus g of x. Remember, this is f of x plus g of x. So I will have 2x minus 8 plus 3x squared minus 5x plus 2. Okay, if you recall, this was something we did way back in chapter R. We're going to combine similar terms. So I'll have 3x squared combining with nobody. So 2x plus negative 5x will be negative 3x. And negative 8 plus 2 will be negative 6. So I end up with 3x squared minus 3x minus 6. And again, don't factor it. We're not factoring. Number two, I have g minus f of x. This would be g of x minus f of x. So I've got 3x squared minus 5x plus 2, and we're subtracting from that 2x minus 8. Again, you're just combining similar terms. Okay, the 3x squared has nobody to combine with. Minus 5x minus 2x is minus 7x. And 2 minus negative 8 is 10. Remember, minus minus is plus. So I've distributed my minus sign. So minus 5x minus 2x is minus 7x. 2 plus 8 gives me 10. So 3x squared minus 7x plus 10. Don't do anything else to it. Number three, fg of x. Okay, this would be f of x times g of x. So here's my f of x, 2x minus 8. Here's my g of x. If you remember back when we were multiplying polynomials, the idea is we're going to distribute the 2x to each term of the trinomial, and then we're going to go down another line and do negative 8 times each term of the trinomial. So if I do 2x times each term, I'll have 6x cubed minus 10x squared plus 4x. So this is 2x times the trinomial. Now when I distribute the minus 8, it'll start off with a negative 24x squared, so I'll line it up with the x squares. So minus 24x squared plus 40x minus 16. So this line comes from doing negative 8 times the trinomial. Now we'll combine similar terms. So I'll have 6x cubed minus 34x squared plus 44x minus 16. And there's your final answer. Oh, I have two number threes now. So f over g of x, remember that's going to be f of x over g of x. So I'm going to have 2x minus 8 over 3x squared minus 5x plus 2. And that's all you can do. Notice the quotient's actually kind of easy. Okay, example number 4, which is actually the fifth example, f minus g of negative 2. So we're evaluating a function at a number. I should get back a number. So f minus g of 2 will be f of minus 2 times g of minus 2. So f of minus 2, replace this x with minus 2, and for g of minus 2, replace those x's with minus 2. So here's f of negative 2. 2 times negative 2 minus 8. Okay, then minus. Okay, here's g of negative 2. 3 times negative 2 squared minus 5 times negative 2 plus 10. So let's start doing some arithmetic. 2 times negative 2, I get negative 4, so negative 4 minus 8. Then minus 3 times 4 plus 10 plus 2. Okay, negative 2 squared gives me the 4. Minus 5 times minus 2 gives me the 10. Okay, this is negative 12, and this becomes 12 plus 10 plus 2. 12 plus 10 plus 2 is 24. So I have negative 12 minus 24, which gives me negative 36. So negative 36 is our final answer. Difference quotients. Okay, this is something that will be needed in calculus. In spite of what our actual course name is, we are a pre-calculus class. We are the algebra portion of a pre-calculus class. Because if you actually look at the name of our textbook, the name of our textbook is not college algebra, it's pre-calculus. The basic difference quotient. Definition: let f be a function. Then the difference quotient of f is given by this thing. It's f of x plus h minus f of x all over h. So f of x plus h minus f of x all over h. Difference quotient is also called these things. It goes by a couple of other names. Okay, the differential quotient, because of what it does in calculus. And number 2, it's also called Newton's quotient, in honor of Isaac Newton, the person we generally credit with the invention or discovery of calculus. The notation that we're looking at is actually due to Leibniz, though, rather than to Newton. Let's try some examples. For each function, we're going to calculate f of x plus h minus f of x over h. Simplify your answers. Do not use mixed numbers, decimals in your answers. Okay, when we're doing the difference quotient, our goal is to somehow, some way, make this h in the denominator cancel. It doesn't always happen, but for really nice functions, it will happen. Okay, now it doesn't happen right away, but notice if it is going to cancel, that must mean you have some factoring going on. How difficult this is to calculate comes down to how bad is our original function. Here's our first one. F of x is equal to 5x minus 7. Okay, a nice linear function. So, f of x plus h minus f of x over h is this. Okay, this first set of brackets, that's f of x plus h. Replace this x with x plus h. So I have 5 times x plus h minus 7. The second set of brackets, that's f of x, which is 5x minus 7. And of course this is h. Okay, when we start working on the numerator, I'm going to distribute this 5, and I'll distribute that minus sign. So I will end up with 5x plus 5h when I distribute the 5, minus 7, and then distribute that minus sign gives me negative 5x plus 7. Okay, so what we've actually done is called expanding the numerator. So after we expand the numerator, I now want to combine similar terms. So I'm going to combine similar terms in the numerator. I'll have 5x minus 5x giving me 0, negative 7 plus 7 giving me 0. So I've kind of highlighted it in colors that almost makes them disappear. So I'll be left with 5h over h. Okay, I can now cancel the h's. I'm left with 5. So the difference quotient evaluated to be 5. Notice the slope of this line is 5. For a linear function, the difference quotient is the slope, but that's only for linear functions. Let's try one with a squared. So f of x is equal to x squared minus 3x plus 7. Again, we're calculating f of x plus h minus f of x over h. Okay, again, the first set of brackets, this is f of x plus h. Replace these x's with x plus h. So I've got x plus h squared minus 3 times x plus h plus 7. And the second set of brackets, that's f of x. And h is still in our denominator. Okay, we now want to expand the numerator. So I'm going to distribute that minus sign. I'll distribute the minus 3, and we're going to square the x plus h. Now, if you cannot remember how to square a binomial quickly, just do x plus h times x plus h and FOIL it out. Remember to square it quickly. Square the first, twice the product, square the last. So that'll give me x squared plus 2xh plus h squared. So all this comes from squaring x plus h. Then when I distribute the minus 3, minus 3x minus 3h, then plus 7. And distribute that minus sign gives me minus x squared plus 3x minus 7. If you notice, these brackets really are no longer necessary because there's nothing going on outside of them. So let's just go ahead and get rid of them. So I've expanded my numerator. Okay, I'm now getting ready to combine similar terms. So what's in color is what's combining. So the yellows, x squared minus x squared is 0. Okay, the pinks, minus 3x plus 3x is 0. The blue, 7 minus 7 is 0. Notice after we expand the numerator, everything that was in the second set of brackets will somehow combine with something from the first set to give you 0. So what we're going to be left with is what you can clearly see. 2xh plus h squared minus 3h all over h. Okay, from the numerator, we can factor out an h. Remember, in order to get the h to eventually cancel in the denominator, sooner or later we have to factor. So every term in the numerator has an h, factored out. So h times 2x plus h minus 3 all over h. The h's will now cancel, leaving us 2x plus h minus 3. And that's your final answer. Let's try another one. I've got an absolute value. So f of x equal to absolute value of 2x minus 7. Now notice in the first two examples we were able to cancel out the h's. If you have an absolute value or a square root or a cube root or something like that, the h in the denominator will not cancel and your answer is going to look kind of messy. So f of x plus h minus f of x all over h. Okay, again, the first set of brackets, that's my f of x plus h. Replace this x with x plus h. And I didn't put any brackets around because it would kind of look funny, just like this looks funny already. So absolute value of 2x minus 7. Okay, notice about the only thing I can do is inside the first set of brackets, inside the first absolute values, distribute the 2. So I'd have 2x plus 2h minus 7, absolute value of that, minus absolute value of 2x minus 7, all over h. There's nothing else you can do. Okay, you cannot separate a sum or a difference with absolute values, just like you cannot do it with radicals. So this is all we can do. Don't try to do anything else with it. So notice with an absolute value, even though it may look hideous, it's actually easier because there's nothing you can do. Number 4, I have f of x equals 2 over x squared. Okay, we're still doing f of x plus h minus f of x all over h. So here is f of x plus h. 2 over x plus h squared, and of course here's f of x. Notice I have a complex fraction. Okay, now remember this h in the denominator is h over 1. So to simplify the complex fraction, multiply by the lowest common denominator of all the simple denominators, which is just x squared times x plus h squared. Because remember, this h is technically over 1. Remember, when we're multiplying by the LCD, we multiply each numerator by factors from the LCD that are not in its denominator. So I'd have 2x squared minus 2 times x plus h squared all over hx squared x plus h squared. Here's the details of it. The x plus h squares cancel. The x squares cancel. So that leaves me 2x squared minus 2 times x plus h squared over hx squared x plus h squared. Now, the denominator is factored, so I'm not going to do anything with it. The numerator, remember, I do need to expand it and combine some similar terms and try to factor. Because again, remember, my goal is to somehow make this h in the denominator cancel. This h is this one. So I'm going to square the x plus h. Remember, square the first, twice the product, square the last. So I have 2x squared minus 2 times x squared plus 2xh plus h squared all over hx squared x plus h squared. We're now going to distribute the minus 2. Remember, we've got to get all the parentheses and brackets to disappear in the numerator so I can start to factor. So distribute the minus 2, and I'll have 2x squared minus 2x squared minus 4xh minus 2h squared over hx squared x plus h squared. So I've distributed the negative 2. combine my similar terms, 2x squared minus 2x squared is 0. So I'm left with negative 4xh minus 2h squared. All over hx squared, x plus h squared. Okay, in the numerator, I can certainly factor out an h. Notice I can also factor out minus 2. So it's kind of your choice. Do you want to take the minus 2 with it? But certainly factor out at least the h. Okay, so here's where we left off before. Okay, all I did was factor out the h. Again, if you want to factor out the minus 2, that's your choice. The h's can now cancel. So I'm going to be left with negative 4x minus 2h over x squared, x plus h squared. Now again, if you want to factor out the minus 2, your choice. I've just chosen not to do it. The alternative difference quotient. Okay, what is it? The alternative difference quotient for a function f is this. It's f of x minus f of a all over x minus a, where a is a number. Now in the regular difference quotient, we had an h in the denominator and we wanted it to cancel. In the alternative difference quotient, we want the x minus a to eventually cancel, which means factoring. Now just like the absolute value didn't do anything in terms of having the h cancel, absolute value won't have the x minus a cancel either. So remember, the alternative difference quotient is f of x minus f of a over x minus a, and a is going to be a number. So for nice functions, f, the x minus a in the denominator will cancel. But again, be aware, it does not have to cancel, just like the h's in the regular difference quotient. Let's go ahead and try some examples. So for each given function, and each number a, find f of x minus f of a over x minus a. Simplify your answers. So I'll give you the function, and I'll give you the value of a. Here's our first one. Okay, I've got a nice linear function. F of x is equal to 4x minus 7, and my a is equal to 3. So f of x minus f of a over x minus a. Okay, here's my f of x, 4x minus 7. Okay, here's f of a, which is actually f of 3. So replace this x with 3, and this, of course, is x minus a, which would be x minus 3. Now, just like with the other difference quotient, I have to expand the numerator. Same thing here. I want to expand the numerator. Okay, 4x minus 7, I can just get rid of the brackets. Inside these brackets, I get 12 minus 7. And, of course, x minus 3 is still x minus 3. So I have 4x minus 7 minus 12 minus 7. Okay. Now I can do 12 minus 7. 12 minus 7 will give me 5. So I have 4x minus 7 minus 5 all over x minus 3. And I can combine similar terms. Minus 7 minus 5 gives me negative 12. So 4x minus 12 over x minus 3. From the numerator, we can factor out the 4. So if I factor out 4, I'm left with 4 times x minus 3 over x minus 3. And to indicate I factor the denominator, I did put parentheses around it. I can now cancel the x minus 3's. And I'm left with 4. Again, notice 4 was my final answer for the alternative difference quotient, and 4 is the slope of this line. For a linear function, the alternative difference quotient and the regular difference quotient is just the slope of the line, but that's only for a line. Let's try something with an x squared with the alternative difference quotient, see what happens. Number 2. I've got f of x equal to 2x squared minus x minus 5, and a is equal to negative 2. So we're going to calculate f of x minus f of a over x minus a. Again, the first set of brackets, that's my f of x, 2x squared minus x minus 2. Second set of brackets, that's f of a, which is going to be f of negative 2. I've replaced the 2x's here with negative 2. And downstairs is x minus a, so x minus negative 2. Okay, we want to start working on this. I want to simplify it and expand the numerator. My denominator, minus minus, will become plus, so that'll become x plus 2. Okay, I can just get rid of these brackets around f of x, and then start evaluating this. Like negative 2 squared will be 4, and minus minus will be plus. So I have 2x squared minus x minus 5 minus 2 times 4 plus 2 minus 5 all over x plus 2. Okay, inside the brackets, I can do the 2 times 4. So I'm going to have 2x squared minus x minus 5 minus 8 plus 2 minus 5 all over x plus 2. Okay, now let's simplify what's in brackets. 8 plus 2 is 10. 10 minus 5 gives me 5. So I'll have 2x squared minus x minus 5 all over x plus 2. Remember, this minus 5 came from doing 8 plus 2 minus 5. Combine the similar terms. 2x squared minus x minus 10 over x plus 2. Now I want to factor. Now this is kind of a nice thing with the factoring. Remember, I want this to cancel. So one of the factors should be x plus 2. To figure out the other one, just look at first terms. 2x squared over x is going to be 2x. Negative 10 over 2 is going to be 5. So I'm going to have 2x minus 5 times x plus 2 over x plus 2. If you check your FOIL, this will become the numerator. So again, all I did was 2x squared over x to get 2x, negative 10 over 2 to get negative 5. The x plus 2's cancel, and we're left with 2x minus 5. Let's try one more, one with that messy quotient thing, fractional function. So number 3, I have f of x equal to 1 over x, and a is equal to 3. So this is going to lead to a complex fraction to start us off. So again, I'm looking at f of x minus f of a all over x minus a. So here's f of x. This is f of a, which is going to be f of 3, so replace the x with 3. And this, of course, is x minus a, which is x minus 3. So I have a complex fraction. Remember, this x minus 3 is really x minus 3 over 1. So my common denominator is 3x. So I'm going to multiply everybody by 3x. So here's my 3x over 1 times the first term, my 3x over 1 times the second term, and of course this is just 3x. Okay, the x's cancel, the 3's cancel. So I'm going to have x minus, excuse me, not x, the x is canceled. So I'm going to have 3 times 1, I have 3 minus x over, and let me put this in correct order, 3x times x minus 3. Okay? Notice these look very much alike. They're opposites of each other if you think about it. Remember how we fixed this when we were doing fractions? Factor out the minus sign. So negative 1 times x minus 3. Now the x minus 3's will cancel. And I'm left with negative 1 over 3x. That's your final answer. That's the end of section 2.2.